With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A ball of mass m is dropped onto a smooth fixed wedge of inclination theta. The collision is perfectly elastic. If, after the collision, the x component of velocity of the block is root 2gh, then the value of theta is. So the question is asking us to calculate the value of theta if the x component of the velocity of the block is root 2gh after a perfectly elastic collision. So the initial velocity of the block before collision, of the ball before collision, which can be denoted by u, is equals to under root of 2 mg into h, as it is falling through a height of h, and the final velocity, which can be denoted by v, is given to us in the question to be root 2 mgh, which is all in horizontal direction. Therefore, we can draw an arrow here and write v. Let initial and final velocities be u and v respectively. As the velocity component along the incline remains unchanged, therefore we can write that v cos theta, as if this angle is theta, then this angle is also theta, is equals to u of sine theta, where let us assume that this is u and this angle is theta. Therefore, velocity in the plane of incline will be u sine theta, and this implies that v divided by u will be equals to tan theta. Since the coefficient of restitution, which can be denoted by E, is ratio of relative velocity of the ball and inclined plane after and before the collision, therefore along the line of impact. Thus, we can write that E will be equals to v of sine theta divided by u of cos theta. And substituting the value of v by u, we can write that E is equals to tan square theta. Since it is given to us in the question that the collision is perfectly elastic, therefore value of E is 1. And we can write that tan squared theta is equals to 1. And this will imply that theta is equals to pi by 4. Therefore, on this calculation, we can say that the answer is option B. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.